This motor vehicle will be moving at a constant velocity of 30 meters per second without any net force acting on it, thereby producing an acceleration of 0 meters per second squared. Having said that, what am I even talking about? Well, I'm talking about the static applications of Newton's law of motion and friction force. Going back to the late 1600s, at the urging of his friend Edmund Halley, Sir Isaac Newton published one of his greatest works that was titled The Mathematical Principles of Natural Philosophy. In this book, Sir Isaac Newton explains on the laws of motion, the law of universal gravitation, and a derivation of Kepler's law of planetary motion, forming the foundations of classic mechanics. Having said that, what is it all about the static applications of Newton's law of motion and friction force? Well, according to Newton's second law of motion, which states, and I quote, "Unbalanced forces acting on an object to produce an acceleration in the direction of a bigger force. This acceleration is directly proportional to the force and inversely proportional to the mass of an object." So this simply means that the acceleration of an object is dependent on the net force acting on it. If the net force acting on an object is zero, the acceleration of that object will likewise be zero, right? Yes. Notice, however, that kinematically zero acceleration does not imply zero motion. It simply indicates that the velocity of an object is not changing. For instance, a 2.5 tons motor vehicle can be moving at a constant velocity of 30 meters per second. If no external force acts on it, be it friction force or air resistance, this motor vehicle will continue in its state of motion. To shed more light on this example, let's look at Newton's first law of motion. Newton's first law of motion states that any object will continue in its state of motion provided that no external force acts on it. So, from this self-explanatory law, we observe that if no external force acts on an object, it will continue moving in its state of motion. However, notice that it is merely because of friction force that an object in motion will come to a stop. What is friction force? Friction force is simply an opposing force that acts between two touching surfaces. Inasmuch as friction force has a number of advantages, it has its own downsides. For instance, friction force causes rapid tear and wear, thereby reducing the efficiency of machines. On the flip side of the coin, friction force has a number of advantages. For instance, static friction prevents the slipping of objects. It is because of static friction that mountain climbers are able to climb mountains efficiently without slipping. Secondly, sliding friction stops moving objects. It is because of sliding frictions that when brakes are applied to an automobile, it comes to a stop. Rolling friction keeps objects in motion. It is because of the rolling friction between the tire surfaces and the road surfaces that an automobile will continue in its state of motion. Fluid friction. Fluid friction enables parachutes to float and planes to fly. In a nutshell, it is very important for us to know more and research more on the static applications of Newton's law of motion, as these are not only important in the engineering field but in our daily lives too. Thank you.